Solving equations, part 2. Now that we're solving equations, we're going to add a little bit of difficulty in and go from 1 or 2-step equations to where we have variables on both sides. So for this first one, I have 3x plus 3 equals 2x minus 4. I can't get x by itself right now because I have an x on both sides of my equal sign. So my first step is going to be to get them on the same side. Okay, now just a general rule of thumb, you don't have to do it this way, but it makes it a little bit easier if you try to move the smaller number with the variable over. Okay, that way you avoid negatives most of the time. So for this one, 2x is smaller, so I'm going to move that one over. Now you don't have to, there are multiple ways of doing this. Okay, it is a positive 2x, so to move it over, I'm going to subtract. That cancels out. 3x minus 2x is x. Bring down my plus 3 and my negative 4. Now to get x by itself, all I have to do is get rid of this positive 3 by subtracting. My 3's go away. X equals negative 7. The next one, same idea. You got 3 times the quantity x minus 2 equals 5x plus 10. So I've got 2 options to start with. I could go ahead and divide by 3 to get the parentheses by itself, or I could distribute the 3. The problem with dividing by 3 is that if I try to divide this side by 3, 3 doesn't go into 5 and 10, so I wouldn't have very pretty numbers. So I'm going to go with distributing. Let's see if I can get rid of those. So if I distribute the 3 times x is 3x. 3 times negative 2 is negative 6. Equals 5x plus 10. Right, I've got a 3x and a 5x. 3x is smaller, so that's the one I'm going to move. Again, you can move either one. So you get negative 6 equals 5x minus 3x is 2x. And bring down my plus 10. Now I have 2x plus 10, but I have to get rid of the 2 and the 10. I'm going to start farther away and get rid of the 10. So I'm going to subtract 10. Negative 6 minus 10 is negative 16. 2 times x, the opposite of multiplying is dividing. So then x equals negative 8. Remember, you can always check your work by taking the x that you got and plugging it back in. Okay, you're going to plug it in and you're going to have a true statement. Now I've got 3x plus 17 equals negative x plus 5 plus 4x. Okay, an extra step or 2 added into this one just because I want to go ahead and combine the negative x and 4x before I move them over. Okay, I just want to go ahead and combine my like terms. Okay, negative x and 4x is going to give me a positive 3x. So I've got 3x plus 17 on this side and 3x plus 5 on this side. So I got to move a 3x over. They're both 3x, so it doesn't matter which one I move. It's positive. The opposite of a positive is a negative. Now when I do that, my 3x cancels. All right, on both sides. So if I bring down what's left, I have 17 equals 5. Now 17 does not equal 5. That is a false statement. Okay, that will never be true. Anytime you end up with a false statement, right, that means that you have no solution. There are no x values, there's no numbers that you can plug in that would make this equation appear a true equation. All right. Now, if you go back to that first line that I wrote here, okay, you notice on both sides I have 3x. That tells me right then that it's going to cancel. Okay, so you can look for if you have the same variable and coefficient on both sides. All right, so for the second one, I'm going to solve for x. I have negative 2 times x plus 1 minus 3x equals negative 7x minus 2 plus 2x. Okay, same as the other one, I'm going to go ahead and distribute the negative 2 because if I divide everything else by negative 2, it doesn't go into 3 and 7. So I wouldn't have very pretty numbers. So I'm just going to go ahead and distribute. So you have negative 2x minus 1 minus 3x equals negative 7x minus 2 plus 2x. Okay, I'm going to go ahead and combine my like terms on each side. So negative 2x and negative 3x gives me negative 5x. Bring down my minus 1. Negative 7x, and this should be a 2. Oops. My apologies. This should be a 2 because negative 2 times 1 is negative 2. Alright, on this side, I've got a negative 7x and a positive 2x. So that's negative 5x and minus 2. Right? You may notice right now that I have a negative 5x on both sides. That means if I go to move one, by adding, both of them are going to cancel out, just like it happened up here. My x's went away. So if I bring down what's left, I have negative 2 equals negative 2. Now that is a true statement. That is true. Negative 2 does equal negative 2. Right? So up here we had a false statement. Down here we have a true statement. So that means that I can plug in any x that I wanted to into my equation up here and it would work out. So that means that my answer is all real numbers, right? All real numbers. Every x value that we can think of works. Okay, so you can write out all real numbers, or we can use that symbol for all real numbers, which is the R with a double stem. Okay, so if you end up with a false statement, it's no solution. If you end up with a true statement, it's all real numbers. And this is not just for what we do in Math 1. This holds true for all your math classes. If you're solving and your variables cancel out, it means it's either no solution or all real numbers. All right, proportions and percentages. Okay, proportions and percentages, they kind of go hand in hand. All right, if you think of percentages, right, you usually think of 100%, right, or you might have 0%, okay, and then if you had, $100, 50% of 100, half of 100 is 50, okay, so anytime you're working with like 100%, it's pretty easy to figure out percentages, right, but sometimes it's not so easy. Okay, sometimes you might want to find, 20% of 82. That's not as pretty of a number, so we use these things called proportions. All right, proportions is just when you have a fraction equal to a fraction, and these are just random variables. Okay, so we are taking a relation and comparing it to a whole. Okay, we're taking it and we're going to be comparing it to percentages. Okay, whatever proportion we look at in here is always going to be whatever numbers we're working with equals whatever percent over 100. Right? We're kind of making a fraction. I know that 20% is 20% out of 100. So that's what my fraction over here is going to be, and I'm going to figure out what should go over here. Okay, I know that seems kind of weird. We'll do an example in a second. Okay, but if I were to give you a proportion like, let's see, 5 over 2, maybe, equals x over 8. This is a proportion. There's no adding and subtracting. It's just a fraction equals a fraction. All right? One way I can solve this is by making my fraction over here have the same denominator as the one over here. All right? So if I could somehow get 5 over 2 to have a denominator of 8, then I know what x would have to be. Well, I can do 2 times 4 to get 8. And then I can do 5 times 4. Okay, so that gives me 20 over 8 equals x over 8. Well, once I have my bottoms the same, if 20 over 8 equals something over 8, that something must be 20. All right? Well, this can be a pain sometimes, and sometimes your common denominator might be a really large number. Okay, so then you still end up with an equation you have to solve. So we've got this cheat, the shortcut for solving proportions. Okay, and it's called cross multiplication. And just like it sounds, we're going to cross multiply. Okay, so we're going to make a little x every time. We're going to say 5 times 8 is 40, and that's going to equal 2 times x. And now I have an equation to solve. To get x by itself, I got to get rid of the 2. I do that by dividing. 40 divided by 2 is 20. Okay, so we're just going to simply cross multiply and solve our proportion. We use this to find percentages of numbers other than 100. Okay, so if I want to find 15% of 100, the proportion that I'm going to set up is whatever number I'm looking for over 200 has to equal the same ratio as 15% over 100%. Alright, every time you write a proportion when you're finding percentages, your bottom right is going to be 100 because it's always your percent over 100. And then I'm going to cross multiply. So I have 100x equals 200 times 15, which is 3,000. I'm going to divide by 100. And my hundreds go away, and then my zeros here cancel. So x equals 30. So 30 is 15% of 200. All right, we want to find 22% of 46. So I'm going to say x over 46 equals 22 over 100. Cross multiply. So 100x equals 46 times 22, which is 1,012. I'm going to divide by 100. All right, easy trick. Anytime you divide by 100, you just move your decimal place 2 to the left. So it goes from here to here. So x equals 10.12. So 10.12 is 22% of 46. And the last one, I want to know 84% of 512. So x over 512 equals 84 over 100. Cross multiply. So we get 100x equals 84 times 512, which is 43,008. Divide by 100. Move my decimal places 2 to the left. So 430.08 is 84% of 512. Now you can kind of logically make sure you're doing this correct. 15% of 200 is going to be relatively small. 15 is kind of close to 0, compared to other numbers that get closer to 100. It's farther away. 30 is closer to 0 than it is to 200. Right? 22%, that's almost a quarter. Right? So that's almost a fourth of the way to 46, which is about 10, right? 10 times 4 is 40. So a little over 10 would be getting you about a fourth to 46. 84% of 512, that's pretty close to 100. All right, so that's got to definitely be on the upper half, getting closer to 512, which 430 is getting closer to that 512. But still not too close because it's not in the 90s or anything. So you can logically kind of double check your work, make sure you're at least going in the right direction.